Okay, good morning, everyone. Those of you at the back, can you confirm if you can hear me? You can all hear me clearly, right? Okay, I want to welcome you to spring 2026 semester, and I also want to welcome you to my class. Before I get started today, I'm going to start introducing myself, tell you about the class expectation and so on like that. So I will advise that you listen and you ask question when you get stuck. So I first want to believe you all for start 4051, right? Okay, so the statistical machine learning. Okay, so uh, that's my name, Kazim Adepoju. I have a PhD in mathematical statistics from University of Ibadan, Nigeria. Has anybody heard about a country called Nigeria? Okay, so I had my PhD in 2016. Of course, in 2015, I secured a grant from Association of Commonwealth University in London, where I had the opportunity of presenting my PhD work at the University of Oxford in England in 2015. So I joined uh, college. My first teaching at college level began in 2010. Of course, I joined the services of the School of Statistics, University of Minnesota in 2018. This is 8 years into my appointment here. I'm also an assistant director of undergraduate studies, also a coordinator of graduate orientation exercise on behalf of the School of Statistics, also a coordinator for summer consulting program for undergraduate. So my area of research, of course, I'm into mathematical statistics, robust statistical modeling, statistical machine learning, and so on like that. Of course, I've published a lot of papers. You can access that online or through the Google Scholar. So, of course, this class is going to be held at this venue, and mechanical engineering 212 between 10:10 and 11. Of course, my office hours is going to be on Zoom because I want situation whereby you're going to be anywhere in the world to attend my office hour. And I have some flexibility when it comes to lectures. Uh, I follow what is going on in the world. There's a lot of uncertainty. Even though I know initially, of course, the world is we live in a probability space, so I'm not surprised on if there's any uh, uncertainty. So because of that, I have flexibility. The flexibility, you can choose to attend lecture in person. Of course, I think I like in-person lecture, or you can under certain condition, or you can also attend my lecture or through the Zoom. So right now I'm recording. I'm on Zoom. I have some students that are currently also attending on Zoom. So in case you have any reason to attend lecture on Zoom, of course you can join the Zoom as well. Okay. And if I'm actually going to have a particular lecture on Zoom. Of course, well, maybe something happen and we're not going to, I'm not going to have opportunity to come to class, something stop me from coming, and I want to do that on Zoom. Of course, you will be communicated. So I will advise that you keep track of announcement session on Canvas. Okay, we all live by information, so keep track of that. So I think there's the primary textbook for this course is that, and I shared the electronic version on Canvas. Is there anyone here who doesn't have, is there any student doesn't have access to Canvas? Okay, you all have access to Canvas, right? Okay, so and we have I have optional, um, the one, the statistical analysis of network data we have. Attendance of lab is very crucial to passing this course because the assignment that I'm actually going to be giving out, you are expected, okay, to complete that using R, um, unless if the instruction prove otherwise. So, okay, so the course web page will be through the Canvas. I believe you all have access to Canvas. And of course, I'm actually going to be releasing lecture notes ahead of time. Of course, this particular lecture have been published before this class. So that's what I'm going to be doing from time to time. Okay. Now, the data is going to be assignment, and a solution to the assignment will be posted or following the deadline. And of course, like I said, we're going to make use of our software for for this particular course. So now there are going to be 10 assignments in the entire semester, but I'm only going to use 9. I'm going to use 9. I'm going to drop the assignment. You have the lowest at the end of the semester. We're going to have 2 midterms. Okay, I will advise you check the dates on Canvas. There's going to be one project, going to be group project. The information about that will be announced as time goes on. There's going to be final exam, okay? But this is what I normally do. Ahead of the exam, whether it be midterm or the final, I'm actually going to release practice questions ahead of time. I'm going to walk you through the practice questions, I'm actually going to dedicate a class, for that, where I give you information about area of concentration, areas that are coming in the exam, what you need to bring to the exam in terms of materials and so on like that. I have tentative dates for midterm 1, February 20. Then I have for midterm 2, April 3rd. And also have a final exam. Of course, the final exam is actually set by the university. It's not subject to, it's not going to change. It's going to remain 8 a.m. to 10 a.m. on Tuesday, May 12th. But the midterm 1, there can be some flexibility to the date of midterm 1 and midterm 2, depending on the way things are unfolding. But for now, those are the dates. Okay, so I will encourage, because I know we may not be able to live successfully in a world in isolation. Of course, I will advise that you collaborate. I encourage your group discussion, but if you collaborate on a particular assignment, I will expect that you have individual, unique submission. Okay, your submission has to be unique. Okay, I just wanted to know that. Okay, no late homework except for re-emergencies. Okay, I know, there can be some extreme events, I'm part of the world, so you let me know, okay? You let me know, so ahead of time. Okay, and if you have a conference submission deadlines, please give a notice at least 2 weeks in advance. Okay, so I think I've mentioned this out of 10 assignment, where I'm only going to use 9 assignment. Okay, even though in the lab we're only going to make use of R. Okay, so when you use a different software, because I actually want to believe every software they're going to give the same results. The coding is what is going to be different. We encourage you to actually use R. But if you use Python and SAS and any other software, I also understand that. But if you get stuck on them, we may not be able to put you through. I'm going to say that again. Okay, if you get stuck on R, we will put you through. We're going to actually put it through. We got your back on that. But if you get stuck on SAS, or any other software that is not R, even though we understand it, I understand our Python and the like, but I'm not going to put you through when you get stuck. So officially, we are using R. And let me tell you this. Arrow is very, very easy to navigate because of it has some of simplicity, simplicity of use. You can be an expert of R within a month. I can assure you that. Okay. Okay. So that's why I said, okay, I think I mentioned this before. Sample exam question will be released before the exam date. Okay. I'm actually going to dedicate a class for that, where I'm going to walk you through that. Okay. And of course, the exam is going to be a closed book. Okay. And I'm going to allow a cheat sheet in exam, the cheat sheet, where you're going to write, necessary things. You can type it, you can, write manually. There's no problem. I have flexibility for that. Okay. And I said, I needed to listen to what I said about the AI language models. Okay. We wanted us to talk about ChatGPT and any other, AI language model. And look at what I said. It's a very helpful tool in many tasks, but it is not a search engine. Okay. And it is not killing Google or Wikipedia, at least in a very near future. Okay, good one to use for exploring ideas and some potential ways of solving your problem. Really do the research by yourself. You need to do the research by yourself. Do not copy from it. Okay, I said do not copy from it, or too easy to backfire, and you won't learn anything from it. Now, let me tell you this. There was a time I had a presentation to make at the School of Statistics. I think that was last spring. And I put the title of what I want to present on ChatGPT. And the ChatGPT actually brought out some content. I was worried that how did this happen? So when I now investigate and I click on a link on ChatGPT, and that very link now take me to CLA. Now, when I go, and I remember that I've already submitted my presentation to the CLA. So the ChatGPT copy what I submitted. So it's not as if ChatGPT is genius. It's not genius. Okay? Even though I actually welcome a situation where I don't lie, I don't learn anything blindly. I also want to know how you get things. I also want to know how you understand things. I want to know how that person understands things. Then I'm going to look at it together. Then that will enable me to bring out a new idea. I'm not going to copy your entire idea. That means I'm depending on your idea. If you make a mistake, that means if I depend on your idea, if you make a mistake, I make a mistake. That doesn't make sense. But it's good to explore ideas. I don't rule it out. You can explore ideas. Okay? Now, keep in mind, they do not really think. ChatGPT don't think. Okay? They don't think. Don't rely on them. But you think. Okay? Okay. Now, I want us to listen. I want to walk us through prerequisite. I know some of you may be wondering, in order for you to best position yourself for excellence in this course, okay, why are these prerequisites necessary? Okay, now I want you to take a look at matrix algebra. We're actually going to make use of matrix algebra in this course, because that is the backbone of statistical machine learning. Let me tell you this, all algorithms, okay, they are all in a matrix vector form. If they are not in matrix vector form, it will be difficult for us to actually figure them out. Okay, so we're going to make use of matrix algebra in this course, particularly when we get into the area of, face recognition, or you want to talk about image processing. Okay, you can't process an image without decomposing an image. Okay, and the idea of matrix decomposition, okay, The idea of matrix decomposition is actually going to be used in image processing. Okay, and that is why we need a matrix algebra in that regard. Okay, like I said, once again, the matrix algebra actually provide, a backbone of statistical machine learning. Okay, and when you talk about probability theory, okay, the probability theory is also essential in statistical machine learning, because if you want to understand how data are generated, okay, if you want to understand how data, okay, are generated, okay, let me tell you this, okay, our intention as human beings is actually to understand the world, okay, because there's a lot of variations in the world that make us to be anxious, okay. If everything stay the same, there's nothing to worry about. My $5, they ask me a lot of questions. They ask me questions all the time. They're going to say, Dad, why can't we be happy all the time? Okay. And my reply to them is, I don't know why we can't be happy all the time, but there's something that I know, that we live in a world that's a mixture of up and down. Even though I want up all the time, I want to smile all the time, I want to be happy all the time, but I should also prepare, okay, that there could be events of the other side of the aisle. Okay, and that is what make world to be stochastic and probabilistic. Okay, and you know what? If you really want to succeed, or if you really want to understand our environment, you want to understand the medical environment, the political environment, the economic environment, you need probability theory, because the probability theory, okay, will enable you to understand when events happen, how those events happen, how they were generated, how data are generated. Okay, the uncertainty, okay, you will be able to understand that. Okay, so that's what I mean, by, the probability, theory. I said it provides a modeling framework, okay, for uncertainty, because we live in a world of uncertainty. Nothing is certain in the world. Okay, nothing is certain. Okay, we find ourselves between uncertainty and certainty. Okay, so that is what is actually guaranteed. So if I actually want to have a probabilistic representation of my data, how my data are generated, the data generating mechanism, of course, that's why you need the knowledge of probability theory. So I'm confirming to you, the probability theory is an essential prerequisite for statistical machine learning. What about theoretical statistics? Okay, the theoretical statistics enable us to learn how to learn from data. If I have data set, how do we learn from data, and how do we generalize? Now let me tell you this. According to American Statistical Association, okay, American Statistical Association, they actually define statistics as the art and science of learning from data. Okay, the art and science of learning from data, art and science of learning from data. I normally tell people, if you want to argue with me, come with data. I'm going to say, where do you learn that from? Show me the data. Show me the evidence. Okay? So art and science of learning from data. Let me tell you this. We want to understand our environment. Okay? As human beings, we actually want to secure our environment. And for us to be able to secure our environment, for us to understand uncertainty around events in a stochastic world, we need knowledge. Okay? Where will the knowledge come from? The knowledge is going to come from information that you got. Okay? You are here in this class. You want to learn about statistical machine learning? You are seeking for statistical machine learning knowledge. Through that, you get information. Information translates into knowledge. But where will the information come from? Information is going to come from data, which means if I have my data set, okay, then I need to apply appropriate statistical machine learning technique on my data set to be able to extract the information that I need. Information are aiding in the data set. And that is the reason why American Statistical Association said they refer to that as the art and science of learning from data. We want to learn from data, okay? And that's why we're here. So the theoretical statistics, we actually provide you, a way to be able to learn from data and how you can generalize, okay? But what about basic programming knowledge? Okay, if I want to actually, because at time I could be working with massive nature, massive data, okay, that we may not be able to, handle or using the manual approach, and of course, when we write a code, of course, we'll be able to figure it out, okay, and that is the reason why I'm actually going to say this. Statistical machine learning sit at the point of intersection of these four. Statistical machine learning sits at the point of intersection of matrix algebra, okay, probability theory, okay, theoretical statistics, and basic programming knowledge. When I talk about matrix algebra, the matrix algebra will enable us to know how model computes, model computation. Okay, that's what matrix algebra is actually going to let us know. How model computes. Please, I need us to pay attention. Okay, I need us to pay attention. So how models compute, but the probability theory will enable us to know how data are generated. How data are generated. Okay, while theoretical statistics will enable us to know how we learn from data and how we generalize what we learn from data. Of course, when you are using the theory of statistics, we normally take a sample, right? We do not have enough resources to study everyone in the population, right? We normally take a sample, and when we take a sample, whatever result we get from the sample, we generalize that. And that is what we call inferential statistics. Okay, so with the knowledge, with the theoretical statistics, that will enable us to know how we learn from data and how we generalize, from that. Okay. Now, what about the programming? Okay, how our models are built and how they are deployed. Okay, how do we build our model? Like, okay, I got models right now, complex model. Okay, if I want to apply this model to data manually, that may be impossible to do. Can we have a way to program my formula? And that's why I'm going to say this. All statistical software, it is the same formula that we program behind the scene. The only difference between the use of the hard software and the use of the MATLAB, Python and so on is just different codings. But we got the same algorithm, the same formula that we program behind the scene. Does that make sense? If you program a wrong formula, do you know your Python, your R and the like, they don't have sense? They don't have sense because even though at times they may flash that, oh, this is wrong, okay, there's something I call garbage in and garbage out. So what you program behind the scene is what really matters. So because of that, the takeaway from here is if you want to actually succeed in this class, then you need to know that statistical machine learning is at the point of intersection of all of this. I'm going to repeat that again. Matrix algebra will enable us to know how model computes, okay, model computation, model computation, okay, how model compute. If you really want to know, oh, I put this code in R and I got this result, Oh, that's a particular formula behind the scene. Okay, if you really want to know theoretically, you need to study algebra to be able to know how the model computes. Now, the probability theory will enable you to know how the data are generated. Okay, that is data generation. Okay, why theoretical statistics will enable you to know how to learn from your data and how to generalize that. Okay, why for the programming, the basic programming, how you build your model, you program that, and how they are being deployed, stuff like that. So that is the takeaway. Okay, now I want to come to learning objectives. Please, I need you to pay attention. In case you don't understand, ask me question. You pay for the service. You deserve to be served better. There's no any question that is stupid as far as I'm concerned. You pay for the service. So ask question whenever you get stuck. Are you ready? Okay. Now, under the learning objectives, we want to understand specific algorithm. Okay, and method is important. Understanding, let me tell you this. I know what I want before going into research, before going into studies. We don't go into a study or research with an empty mind. We got something in mind that we want to figure out, which I'm actually going to call intentions. Intentions. Okay? You have an intention going into research. You have an intention using an algorithm. We don't just do what we do. We got reason why we do what we do. So my intention may be to explain. Do I want to explain why things happen? That may be my intention. If I want to care about explaining how things happen, the statistical method that I'm actually going to do, what I'm going to use is going to be different from when my intention is prediction. There's a difference between explanation and prediction. So you need to be able to tell us, what is your intention? Do I want to predict or do I want to explain? A modus that we use to predict may not necessarily be good for prediction or for explanation. We got modus for explanation. We got modus